Hi, Paramanand Ashok Pawar, working as an assistant professor in Electrical Engineering Department, NB Navale, Sinhagad College of Engineering, Solapur. I have completed BE from Government College of Engineering, Jalgaon. After that, I have completed my MTech in Power System from TIT Bhopal. Currently, I am having a 8-year teaching experience. Today, we are dealing or discussing one of the important topic of a synchronous motor because the synchronous motor is used as a synchronous condenser. Sometimes it is called as phase advancer or phase modifier or synchronous compensator, which is used for the reactive power management of a transmission line. So will discuss the detail about the synchronous condenser. So this is the diagram of a synchronous motor which is used as a synchronous condenser or synchronous capacitor, which will shows the frame, stator circuit, rotor circuit, the damper winding, the another name of damper winding that is called as the armature winding, and the exciter circuit which will be shown, which is used as a capacitor for a reactive power management. Okay, so as shown in first figure. So in first figure there is a supply, that is three-phase supply is available with us, that is RYB. That three-phase supply is given to a load. So for that particular load management, a synchronous condenser which is used as a synchronous phase modifier is connected to that particular three-phase line, and the function of that particular synchronous phase modifier depending upon the load requirement, it will supply or absorbs the reactive power management. So the another diagram of the synchronous condenser which will be shown, that is, this is the diagram again in which the three-phase supply is given to the three-phase load, but in that case the synchronous motor is used as a capacitor for supplying the reactive power and management. So as shown in figure, there is P is the reactive power, Q is the reactive power, and here that is delta connected C, which is basically a synchronous motor which is used as an synchronous condenser or synchronous capacitor, which will supplies the capacitive, that is leading power factor, when the three-phase load has a lagging load. So that particular application, the synchronous motor used as a leading capacitor for a reactive power management. So we'll discuss in detail. When the motor power factor is unity, the DC excitation is said to be a normal. When the DC excitation is given to the rotor circuit, that time it's said to be a normal. But when the overexcitation causes the motor leads operating in a leading power factor, means as we know that there are three excitation states are there. First one is called as normal, second one is overexcitation, and third one is called as underexcitation state. So the overexcitation state, it will be provide a leading power factor, and underexcitation causes the operating in which a lagging power factor. So the important concept is that when motor is operate at no load with overexcitation, it takes a current that leads the voltage by nearly 90 degree. So in this way, it behave like a capacitor and called as synchronous capacitor. It is also called as synchronous compensator, or it is also called as synchronous phase modifier. So the synchronous compensator is therefore a synchronous motor running without mechanical load. It can generate or absorbs the reactive volt ampere, that is Q, reactive power management kVAR, by varying excitation of its field winding. So basically these cases are, if the load has a lagging power factor, then this synchronous motor will provide a leading power factor, means this synchronous compensator is used as an capacitor which will leads the power and hence the total transfer capability of a transmission line is increased. So this motor behaves like a capacitor. Sometimes under excitation state, taking or lagging current, therefore it supplies a reactive, that is absorbs inductive reactive power. Thus, current drawn by a synchronous capacitor can be varied from lagging to leading depending upon the change in excitation. In simple way, when there is a load which will has a lagging power factor, that time this synchronous motor will supplies a leading power factor, supplies reactive power, that is leading power. If the three-phase load has a leading power factor, that time this synchronous motor, which is used as a synchronous capacitor, which behaves like a inductor, which will absorb the power. So in this way, this synchronous motor is used for basically the reactive power management, which is called as compensation of a transmission line, as well as the power factor improvement of a transmission line. Thank you. Thank you very much.